In this lesson, we're going to be talking about one of my favorite algebra topics, and that is polynomials. Before we get into polynomials, take a minute, get out a piece of paper, get out a pencil, and write down the answers to these 7 questions. Hit pause, answer the questions, and when you're finished, come back and we'll look at the answers. Make sure you do write this on paper, and make sure you bring it to your next class, because I may check. Alright. For number 1, if you got 7, then you are correct. Number 2, at 13 you are correct. Number 3 is 2. Number 4 is 69. Identify the coefficient. Hope the number coefficient is the number multiplied by the terms or the variables. In number 5, 4 coefficient. Number 6, 1 is coefficient. There's not a number in front of that variable, so it's an understood one. And in number 7, 2 is the coefficient. Alright, so here we go, talking about polynomials. Before we go far in here, I'm going to talk about polynomial. Poly, hopefully, poly means many. In other words, it's poly, like polytheistic, a belief in many gods. Polygamous is a person who has many wives. Those are the 2 that come to mind now. And nomials are numbers. So basically, things with many numbers. But it's not just numbers, it's also numbers and variables. The most basic type of polynomial is called a monomial. And the prefix mono means one, fancy word for one term. And it could be just a plain number, it could be just a plain variable, or it could be a product of number variables. So be numbers and variables multiplied together. If it's a monomial, it only has whole number exponents. It's not going to have negative exponents or frac exponents. And here we have some examples of monomials. 5 is a monomial because it's just a plain number. X is a monomial because it's just a plain letter variable. Negative xy is a monomial because it's a product of numbers and variables. Notice there is no addition, there's no subtraction, there's no division. Monomials would only have multiplication. And then half x to the 4th, that's also a monomial. Just all multiplication. These are examples of things that are not monomial. Negative 3/10 x to the negative is not a monomial because it doesn't have a whole number x. 4x minus y is not because it has subtraction. Remember, monomials have multiplication if there's any operation. And 2 over x to the 3rd is not because you have division in there. When we're talking about monomial and also later polynomial, we talk about degrees of monomials or degrees of polynomials. And a degree is all about the exponent. Degree of a monomial is the sum of the exponents of the variables. So, for instance, if you have the monomial 2x squared, the degree is 2 because the exponent of the variable, there's only one variable, so this monomial has a degree of 2. In the number 4, is there a variable in it? There is not. Since then there's not an exponent, c of that is 0. This is a constant, has a degree 0. On the next page I have a chart of all the names. If something is degree 0, the name of that is a example of a constant is 7. If degree 1, it's called linear. So x is a linear because what's the exponent of x? It's an understood 1. Degree 1 is linear. You could have a coefficient in front of that x. You could have 5x. The exponent of the variable is 1. So it's linear. Again, degrees are all about the exponents of the variables. If something's degree 2, means variables have an exponent of 2, like 5x squared. Exponent has of 2. That's quadratic. Now I want to show you a little more complicated example. If you have the monomial xy, what's the exponent of x? It's 1. The exponent of y is 1. And if you have more than one variable in a monomial, to find the degree you have to add all the exponents. So 1 plus 1 is 2. That makes it degree 2. That makes it a quadratic monomial. A cubic monomial would be a monomial that has a variable exponent of 3, like y. Third, degree 4 is called quartic. Degree 5 is called quintic. After degree 5, if you have degree 6, 7, 8, if you have degree 21, you just say 21st degree or degree 21. Now, you guys need to make sure that you learn these names. You need to memorize them. You need to be able to identify them, and you need to know how to spell them. So make sure you study these: constant, linear, quadratic, cubic, quartic, and quintic. Let's look at some examples down here. I'm going to do the first 4 with you, then I'm going to pause it and figure out the next 4. The degree of 4x. Look at the variable. What's the exponent? It's 1. Degree 1 is called a constant. No, sorry, that's wrong. I wonder if you caught me. Not constant. Degree 1 is linear. In example B, there is no variable. If there's not a variable, this one's a constant. I got ahead of myself before. Example C, the exponent of the variable is 4. Degree 4 is quartic. In example D, there's 2 variables, so we need to add up the exponents of both of them. A has a degree of 1, an understood 1 has a degree of 1. So you add up both of the exponents, you get 2, so this is quadratic. Alright, figure out what the degrees of E through H are. E is a constant. F is a cubic. Now G, we have a degree 2 and a degree 4. Add those together, you get 6, so this is 6 degrees. And A is quintic. That should be a Q right there. Alright, these are degrees. Degrees, again, about the exponents of the variables in a monomial. If there's one variable, add up the different exponents to get a total degree. Alright, some more vocabulary. A polynomial. Remember before we were talking about monomials, which are monomial, poly meaning many. A polynomial is going to be a monomial. So plain old monomial is a polynomial. Or it's a sum or difference of monomials. So if you add a whole bunch of monomials together, that's a polynomial. If you subtract a whole bunch of monomials together, that's a polynomial. If you do both add and subtract, that's a polynomial. And I have some examples. One term polynomial. Remember, terms are separated by a subtraction. 4x squared plus 7. This is a 2-term polynomial. 4 squared is a monomial by itself, or one term. And 7 is another monomial. Add them together and you get a polynomial. And then this is also a polynomial. In 5x, do you know what the coefficient is? The number in front of the variable is the coefficient, so 5 is the coefficient. The variable is x. In the second polynomial, 4 squared plus 7, what's the coefficient of this first term? It's 4. In the second term, that's called a constant. Just a plain number is a constant. So, when you talk about a degree of an entire polynomial, it's the degree term with the greatest degree. So for instance, in this monomial, hopefully you know, there's only one term. So this is degree 1, or this is a linear polynomial. In this second example, x squared has a degree of 2, 7 has a degree of 0, which is bigger, 2 is. So the degree of the entire polynomial, degree 2, which is quadratic. Third one, the first term in this polynomial is degree 3. The degree of the second term in this polynomial is 1, and the degree of the third term is 0. So the degree of the entire polynomial is the same as the degree of any of the terms. So this is degree 3, or cubic. So a degree of a monomial is just the degree of the exponent in that one term. If you have a whole polynomial or a bunch of monomials together, whatever is your largest degree is the degree of your whole polynomial. Alright, you know how we talked about standard form of a linear equation? Form of polynomials. The reason for having a standard form is just so that every world would write their polynomials in the same format. Because you know when you add and subtract things, really the order doesn't matter because of the commutative property. So that in order for everybody to write them in the same form, they developed a standard form. So standard form of a polynomial is when the terms are written in order from greatest to least. So you'd have your biggest degree first, your biggest exponent first, and then write them in decreasing order. For instance, in this example down here, what's the degree of the first? The degree is 0. What's the degree of the second term? 2. The degree of the third term is 1. And the fourth term is 3. Are these in descender? They're not. So this is not in standard form. However, in this other example, we have degree 3, degree 2, degree 1, degree 0. So this polynomial is written in standard form because the degrees are written in decreasing order. You'll also hear people talk this thing called the leading coefficient. Leading coefficient is simply the coefficient of this term when a polynomial is written in standard form. A polynomial has to be written in standard form in order for you to talk about what the leading coefficient is. In this polynomial, where it's written in standard form, the leading coefficient is 7 because that's the coefficient of the first term. So here I have some examples. Let's go through and write these polynomials in standard form. Let's identify the leading coefficient and the degree polynomial. In this first problem, you got to look at each term and look at the exponents of the variables. What has the big? This negative 7x to the fifth. Make sure when you're writing polynomials, you keep the sign of the term. This has a negative in front of it. Write it. It's still going to have a negative in front of it. Negative 7x to the fifth. So I took care of that. What's the next highest exponent? 4x squared. That has a plus in front of it. So plus 4x squared. We took care of that one. What's the next biggest power? 6x, a positive. So we have plus 6x. And all that we have left is a plus 9. So we have this written in standard form now because we have biggest 3, 5, 2, 1, 0. Now we can identify the leading coefficient. The leading coefficient is negative 7. And the degree of the polynomial, what's the greatest degree of any of those terms? It's 5. So this is a quintic, oops, sorry, I misspelled it, polynomial. Alright, why don't you try the second one on your own. Hit pause, work out your answer, and then come back and see if you got it right. Standard form would be y to the sixth plus y to the second minus 3y. The leading coefficient, there's an understood 1 in front of that, so it's 1. And the degree of the polynomial, it's the sixth degree. Moving on, not only do you name polynomials based on their degree, but you also name them based on how many terms they have. Let's go back here for a minute. In example A, how many terms is this polynomial made up of? Remember again, terms are separated by addition of 7x. The term positive 4x squared, positive 6x is a, and then plus 9 is a term. So this polynomial is made up of 4 terms. How about this polynomial? We have 1 term, 2 terms, 3 terms. So this polynomial only has 3. Again, however many terms a polynomial has, they have names as well. If you only have one polynomial, 4x, that's a mono. If you have 2 terms, it's a prefix bi, it's binomial. A bicycle has 2 wheels. Binomial has 2 terms, so we have 2x minus y. 1 term, second term. A trinomial is a polynomial that has 3 terms, 4x squared plus 3x, or 3y that looks like, minus 1. That's a trinomial. And anything more than 3 terms, you just call polynomial. If you have 4 terms, 5 terms, 28 terms, you call polynomial. All of these are polynomials. They just have more specific names, like a binomial or a trinomial. Similarly, you know, that's a terrible, I was trying to make a square. That's a terrible looking square. Let's see if I can use the magic pen. Supposed to be square, but this is a polynomial, right? A many shape, but specifically, it's a quadrilateral, only has 4 sides. So this is a polynomial, but specifically, it's a trinomial. Alright, in these examples down here, we need to classify or name each polynomial according to its degree and by the number of terms. So we have to look at 2 things, how many terms and what's the degree. In example A, how many terms are there? We have 1 term, the 5n cubed, and then 4n squared. So that's 2 terms, making it a what? That is a binomial. And the degree of that binomial, the biggest exponent in any of the terms is e. So a cubic binomial. Generally, you put the degree name first and then the term name second. In example B, we have degree 6, so 6th degree. Terms are there, 1, 2, 3, 4. So that's a 6th degree polynomial. And our last, this is a degree 1 or a linear. There's only 1 term, so it's a linear monomial. Now these are the basics of polynomials. You can name polynomials, have different degrees based on the exponents. You can write them in form. They're made up of coefficients and bills. And as we finish this chapter, we'll be adding polynomials, we're going to be subtracting polynomials, and we're multiplying polynomials. Please make sure you look at the names in degrees and terms and you know them. Before we finish, I want you to see how well you understand. I have problems here. Pause this video, write down the problems, write your answers, and when you get to class next, we'll check them and see how you